Good morning, everyone. Thanks for attending. My name is Mike Reed. I'm a BI consultant at Pragmatic Works. Today's topic, applying big data analytics to business decisions. We'll talk about questions you can ask, how to support those questions. We'll walk through some scenarios using Excel and Azure data mining, machine learning utility. Really interesting stuff, and then we'll do a quick recap on what we talked about and what we think we can do, and potentially how to set out about implementing a solution. So let's get started. So what questions can we ask? Truly, you can ask pretty much anything you want, but what questions would be typical? So, the easy ones to answer are forecasting, sales, forecasting some, linear, maybe I need to explain something here. So there's a couple of data science terms, if you will. There's linear variables and there's discrete variables, much like, your functions and your SQL Server functions. Discrete indicates that there's some limited set, and continuous would imply that you're looking at a time series or you're looking at age, where it's, in theory, that stops at 100 and something, but it can be any value in between. So there's a theoretical infinite number of values in between. So depends again on what you're trying to do. So forecasting usually, whether it's sales or number of employees or number of stars in the universe, whatever, usually refers to some sort of continuous variable as the predictor. You could be looking for sequences. You could be looking at how is somebody using my website. This is one I've talked to people about quite some time and don't see analyzed all that well. You can get a little bit of this information from like Google Analytics, but not a lot. You can't really see the path that somebody took to get to a page, and more importantly, you don't always get to see what's called a conversion. Did the viewer actually take the intended action, whether it's going to another page or clicking on this this ad to buy something? Was there did they do what you need to do? What you wanted them to do. Analyzing machine data, looking for sequences of events that predict that indicate. It's not really, when you're analyzing, it's really past tense. It's indicating a failure, and then using the model you've built to look for those patterns and predict a failure in the future. Looking at health practices or healthcare, you could what happens to what's satisfaction with patients when they show up, what makes for a happy patient, what makes for a good visit, what makes for an effective visit, and what, as or more importantly, makes for a bad one. Very frequently, we've all heard about market basket analysis. What did people buy? What do they have in their basket, or what? And that leads to a recommendation engine saying, well, if they have these two in their basket, based on past behavior. And this is kind of interesting. I'll go off topic a tiny bit, but I was looking at something recently and saw that looking at Amazon and Walmart and all the companies with a big retail presence, none of their recommendations are based on predictions. They're actually all based on past behaviors. So they only have to, they've taken a giant element of uncertainty out actually by just saying, well, so many people did this and there's a high probability of this, and the more we know about the person that's actually doing the clicking or purchasing, the more certain we can be that they're going to take this next step. And so we'll recommend these other items, and it doesn't again have to be a shopping cart. It could be anything with a similar behavior. We could be looking for, I want to see, I want to understand who my customers are and what makes them up, and what demographics maybe. We'll take a case of you even using the simple AdventureWorks bike data, bike buyer sample data. If you take your sales information that this person bought a bike, and you link that back to demographics about this person, and you link that to some geography information, and then adds in some data information, you can reasonably well predict what your sales would be, or what you might want to market, when and to who and where, literally across the planet. So there's a lot you can ask of your data. The big deal, and on to the next slide, is really what your data supports, and that's very often between that and talent is the most limiting of the factors. So patterns, you're typically looking at, almost anything can be evaluated for a pattern. The issue is that you may or may not have, your data may not be disparate enough. There may not be enough of a change in the patterns for some utilities. I've experienced this in Excel once in a while, to actually be able to detect a pattern. It may come back and say, well, they all look so similar that we can't really predict it. There are other tools, and I'll show you this here in a little bit. Like I did the same analysis using the R programming language, and it came back, and I can actually see the relationships of the clusters, and they do exist, but they do demonstrate that there's really not a lot of separation between them. So the analysis may not be worthwhile. That says the confidence in the separation is fairly low, and trying to make take any action on that would incur substantial risk. So again, we can look for patterns. That's usually a clustering sort of algorithm. Might be a decision tree. Unusual behaviors could as well be. Could be a sequence algorithm, or clustering again, where you're looking for that one anomaly that caused some desired or undesired behavior, and you'd like to either repeat or not repeat it. Associations typically will say these things happen together, and I'm going to use that information augmented by more about who did it, or when they did it, or what did it, to encourage some other behavior. I won't necessarily say predict, but encourage some other behavior. And then there's prediction itself, when you may finances again, easy example. So my sales were this, and my expenses were this, and I need to project my wages are, labor's moving. How are they going to converge or diverge? What does that look like over the next X period? So obviously, when you start talking prediction versus application of observations, you encounter rather an additional margin of error that has to be accounted for. So where do we start? This kind of comes back to something, it does come back to something I talked about in my last presentation, part 2. It has to do with the analytics life cycle. So you need to pick a question. That in theory should be something, if it's going to be funded, it would have to be something that would have some value to a business. And the value doesn't have to be monetary. It can literally be any currency. But you really need to isolate the question and be very specific about what it is that this problem you're trying to solve. Are my sales dropping off? Are my employees leaving? Is my customer churn too high? Some of them, they're seemingly simple questions, may not be really so easy to answer. As important as the question is to define the goal, and that's kind of what's the success criteria for this project. How do we know when we've satisfied the project and we can stop, or I'll stop there. So after that, you can take a look at the mining techniques that would satisfy the question. Quite a variety, huge variety actually, and depending on what you're doing it with. If you're using Excel only, then you're fairly limited. But if you're using the other extreme, something like R, which has been around for a very long time, 30 years. Well, R itself not, but has been around for a very long time and is very mature. The options are almost unlimited, and everything in between. Azure falls, machine learning falls somewhere in between that. So choose the mining technique, and then you have the issue of how do I prepare my data? What does it need to look like to support the questions I'm asking? Do I have, if I have all of my machine-generated data, my machine logs, do I also have an indicator in there as to the health of the particular system you're monitoring? How do I have to, I can't, if I have to guess, then there are some algorithms you can't use. Some of them look for, again, refer back to the simple case of the bike buyer. Did this person buy a bike, or did this person not? And so did this set of if I look at a point in time for this particular machine, was the system healthy? Was the system operating within parameters, or was it out of parameter and heading for an error, or already causing an issue? So being able to very specifically quantify a failure, or bucket the information and quantify the anomalies that would make up that would lead up to an error is obviously critical in there. And the more accurate you can be there, obviously the more accurate your analysis and predictions in this case would be. Next, to execute, and that typically means running it more than once. The issue with a lot of these algorithms is that you can't run them just once. You really need to run them multiple times and over. As an example, take a clustering algorithm where you're just looking for patterns. They all start on the premise that if I say I want to see 5 clusters, it actually picks 5 points within the range of your data, and will start building clusters around that. It'll start moving points in your data towards the points that are most similar, and it iterates through this cycle until it can't improve on or sees a marginal improvement on the cluster, on the clustering. So it starts with that kind of arbitrary assignment of cluster points, and there's actually a number of a number of methods that can be used to choose how those start. But the bottom line there is running it once is not going to work. Running it multiple times, and it could literally be hundreds. Fortunately, it's a machine doing it. Running it hundreds of times might be important, and recording, recording the fit, or evaluating the fit afterwards, then going back and choosing your model would be the method for actually determining what you actually move forward with. Validating the analysis, so that means going back after you've chosen your model to go back and actually run this analysis on a set of test data. Procedure is when you run your initial analysis, you will set some percentage of your data aside to do your testing with. And when you have settled on a model, then you'll come back and validate the accuracy of the model against a set of data with a known output or a known action. In the case, is it a bike buyer? Yes, you can run your model and see if your prediction, if your analysis actually supports the or what your margin of error still is. And obviously, you want that to be slow. And this whole process, refine and repeat. So, are you going to get it right the first time? Are you, probably it would be probably unlikely, I would guess, unless you're asking a really simple question. And a simple question, the people that are asking probably have enough experience to be able to tell you without, what the outcome is going to be, without, making an investment in some sort of analytics to support what they probably already know. So let's move on, and we'll talk about some examples here. So let's start with drag this over here. Hopefully everybody can see this all right. So what we have, let me go back here for a minute and we'll talk briefly about this, this simple bike buyer scenario. I hate to keep bringing it up because it seems trivial, but it really demonstrates the point. So you have data about somebody. Let's start with bike sales. So you have some sort of sales or some sort of event recorded. Somebody took some action, whether they're clicking around on your site or whether they're buying something, or whatever it is you're trying to get them to do, or the event you want to see happen. You had a positive outcome or some outcome. In this case, they're all positive. Somebody bought something. So you feel good about that. But you can now take this and say, okay, I have these positive actions that have these impacts, which would be, our price. Sorry, I'm just had an issue in my second presentation with some demos and my screen froze. It looks like it's still doing all right. I could get that out of the way. So, the desirable action occurred. It had, some impact. Well, I sold a $2,400 bike, but I can take this information and I can hook it up with my with what I know about my customers, and whether this is another business or in this case, a person. What do I know about these other businesses? Where are they? What kind of business are they in? Anything that you can learn is always important about your customers and your competition. But so I can connect that information with my customer information, and now I have a profile that gives me the ability to say, okay, this person. Actually, let's take the person out. I now have a direct link between a positive action and some set of demographics. So I can say, we'll call it characteristics. So again, it could be, a business of this size, with this many people, or this kind of revenues, or they took these actions in the last year. I have more information about my customer that I can apply to the sale, and I can infer that who they are and what they are had some influence on the sale itself. And that's the basis for all the predictions, is I can now say, based strictly on some set of attributes for the customer, or some set of attributes for the customer, I can assume that this particular group, they've demonstrated a strong positive behavior. So I want to find the guys that I want this customer that had this kind of influence on my sales, hopefully revenue as well, but had this kind of influence on my sales, and I can come back over here now and say, this particular set of attributes contributed most to this particular group, and if they have this, in the case of the bike buyer, the number of cars they have, their income, distance from work, marital status is a big one in there, but if we look at the analysis itself, it'll tell us that really 2 or 3 of these attributes drive 80% of the behavior, and those are the ones you'd want to focus on in your marketing or your process improvement, whatever it is. Another situation where we might want to answer some questions. What can I do to improve? In this case, this is a survey at the San Francisco airport of the facilities, and well, really it's all facilities. So overall satisfaction with facilities is everything. Are they what influenced? What's their attitude towards the airport? And not that people are going, well, I'm not going to that airport unless it's totally unsafe. So this has limited use from the standpoint of saying we need to draw more people into our airport. It might have more use to the airport if they want to talk to the retailers in the airport, or determine whether the security has enough of a presence, or whether they have incidents in the airport where people are incensed by the condition of the airport itself, or the distance to bathrooms or whatever. So a lot of questions, most of them binary. Where are they from? What was their satisfaction level across a number of attributes? Again, this data could be applied to really any scenario, almost anywhere, where you have the ability to either directly, in this case, by asking questions, or indirectly by evaluating people's behavior and assigning, or a business's behavior and assigning attributes like how many purchases in the last year, what's the size, what's the total dollar revenue of the company, how many locations are they in across the country or across the planet, where are they? These attributes can be pretty much anything, and you can still do the same kinds of analysis. You could do, against this data, you can do a simple cluster where you can say, in my case, actually an example I worked up was I wanted to look at who's in the airport, who these travelers are, looking at where they're from, the destination airport, their age, gender, and income range, and the number of flights, to see if there's any correlation between that and their overall satisfaction with the airport. So okay, where are we? So I decided to approach this problem as okay, I want to see who the happiest people are. So I went for overall satisfaction of 5, which is the max on their scale, and said, who are these people, and what can I learn about them? So we tried a clustering algorithm. I did a demo on Excel last week, so I'm not going to talk about what each of these does too much. I will, as a function of this one, put up some fairly extensive tutorials on my website. So if you have questions about it later, keep checking back. It's a lot of work to put those together, but I don't find enough material out there to go through and actually explain use cases for each of them. So here, all I'm doing, I'm going to say I want the whole table. Here I will come back and say I want to see, I'm going to pick an arbitrary, this is those cluster points I was talking about again. And I'm going to say I want, let's take this as country, age, gender, income, flights, and I believe the last one down here, overall satisfaction. So here's where we would set aside, this percentage, and we're just going to run this as is. And it came back and built this for us. So it said, okay, there are some clusters here. It's saying that our cluster 1 and 2 are most similar, have the strongest relationship, in fact quite strong, so we can go here and we can look at cluster 1 and what determines that. So obviously 5, we know that. US, 2 is female, and 1 flight. 1 is 0 is unreported, 1 is low, and so back here to 1. And we have, well, I guess it would be strong. So here we have, again, the satisfaction 5. It picked that out pretty quickly. US, gender, same. Number of flights. All this really did was add in looks like some males. Age between both, brought that into play. Flights, again, more flights. So it starts to get into these less influencing factors. It's saying that age in this group is less important. They're all down in this space. It's really gender driven, and with a cumulative age. I'm actually kind of surprised it came back with these. They are so similar, which is why when you over here this slider indicates the strength of the links, and the weight of the line here is a visual indicator of that strength. Like this is saying cluster 3 is related but quite some distance back. Let's look at cluster 3 real quick. Um, 5 is the highest here, so this is I think it's probably over 100,000 a year, males and females. 5 is the highest range. It would be over 55, I believe. So very distinct group. Explaining why there's no relationship here until you get way down the line. The bottom line is, it came through here and created these clusters to say, okay, and here's how they relate. What this really doesn't show us here is much about the probability that these are solid clusters. Again, we started with some number of arbitrary points. I said 5, and the algorithm started with arbitrary points. So we have the issue of, is this solid, and would I necessarily hang my hat on it? Probably not. So we can go through the cross-validation, and here it will take our set. Let me see if it's got it in there. And we'll assume this is our last. Next, and we'll use our number of folds as how many times it attempts to do this validation. Target attribute. That's interesting. I love it when it does that. So here it comes back with with probabilities of how accurate this is. As a rule, 0 is best. When you get up to, and the values are only between 0 and 1. So a lot of these have, would this cluster be repeatable, and is it distinct enough to, or this algorithm distinct enough? Maybe, but probably not. We do have the ability to, see which one I've got here. One of the beauties of some other work. This is the same data, and this is what essentially what I've learned in 6 months of this data science course. Is I can take this same data, these same attributes, and I can now come in here and I can actually see how, visually how they align, and I can also see the composition of these clusters. So that's the upside of working in a technical language like this versus a user interface. So here, this gives me all my statistics relative to each of the groups. What gender are they, what's their income, etc. So I can see a little more about how they align with each other. There are other utilities in here that I can run that will do essentially what they call it's a bootstrap. It will run the algorithm over and over and over by default 100 times, and then save that data and write it out so you can take a look at it and go, okay, how is this model actually performing? We have the ability to do something very similar in Azure. And this is their machine learning console. So here's their home page on their the machine learning console. So out here they have all sorts of samples, and I'm going to go into a little more detail with this because the part 2, none of this was showing. The GoToMeeting apparently froze, so I'll talk a little more about what's out here. So the deal here is that you can use Azure if you so desire. I don't have my my console up. So you can use Azure to store your data, to pre-process your data. You can use, if you watch my first presentation, I've got a bunch of scripts that I wrote and created a Visual Studio project. I created a Visual Studio project. I also created a set of scripts that you can use, and here I have them in the PowerShell scripting environment. So I built a library of scripts that will let you upload data, create clusters. So be aware your storage exists. Hopefully you create it in this manner. You create a storage account in the storage container, and that exists all the time. So I can load data into it, and it stays there regardless of what I do with a cluster, whether I fire a cluster up or not. It's already there. If I need to do some processing, then I need to have an HD Insight cluster running, and then I can use, I've got some other samples I have open here for pig and hive scripts to manipulate the data, some MapReduce scripts that do some additional manipulation just to kind of demonstrate what you can do. But you can use the Hadoop environment separate from the storage, the Hadoop environment, to manipulate your data and get it into a format that it's cleaned up and ready to use. And then you can shut your cluster down. and still have your data sitting there. The output of Hadoop is always a file that it writes to storage. So if you write it someplace that isn't destroyed when the cluster shuts down, then you can still go back and access it. So to do this machine learning stuff, you don't have to have a cluster up. You didn't have to actually use it in the first place. I have some data out there that I created in Excel and manipulated in Excel and connected to my storage container and moved it out. I can write directly to it, or you can use something like this other tool I had mentioned in my previous demonstrations. The first one is this thing. It's very much like an FTP client. This one I have pointed at my storage container, and here's my storage account, my storage container, and here's the folder I'm sitting in, and this one is sitting on my computer. So I can take files that I've created and push to somewhere on my computer, my local file system, and literally move them back and forth. You know, it's just this kind of simple to move these around. So it's you know, there's a lot of nice tools to help you out. You don't have to have an HD Insight cluster running. Storage accounts are pretty much free. You do get charged for some bandwidth as they go in and out, but the bandwidth is really inexpensive. So if you feel like playing with it, maybe you want to do your work in SQL Server or Excel, you know, Power Query, and then push everything out to a storage account, storage container in Azure, and then you could fire up these experiments. This whole thing is in beta right now, so I don't know that I'm actually going to incur charges until there's a final release. But it's been in beta since July, so it hasn't been out there that long. I imagine they'll keep it up for a while. Let's pick on one of them that I did, just because they're a little simpler, easier to understand. So here, all I'm doing, looks very much like SSIS again. It's all drag and drop. You know, if I need to add go read data from somewhere, I literally just drag this over, and over here you'll see your configuration. Depending on where I want to get it, it could be output of queries. In my case, it's blob storage. So this one I have set to blob storage, give it my account and account keys, and tell it where to put it, actually where it is. Sorry, it's a reader. And it'll go out, and it goes out and reads it in. In this case, I wanted to do a little transformation, so I wrote a little bit of R to. All this is doing is concatenating a couple of columns to create a timecode column, a single timecode column. I have a part 1 and part 2. This kind of points up that there is no data. There's filtering in here, and there's a little bit of transformation, but as far as as far as heavy duty data cleansing and such, not that capable in here. As a rule, you're going to want your data set to be clean when you read it in, or as clean as possible when you read it in. The examples, I'll show you these in a bit, that they've included on the site. They use most of these to take output from some task where they might run a clustering task, and they may want to split it to drive it to multiple places, or they may get a lot of columns out of it that they don't need down a particular data flow path. So they use a number of these tasks to do that. In my case, I wanted to do something. I kind of wanted to see how it worked too, so I haven't done a lot out here. And this is standard R. The only parts that are different is how this is structured. Everything on the left of the assignment operator here is standard, and then here they're using a .NET class, I assume, to write this back out. So this is reading, it's taking this data from this input, it's pasting these together, and then it's passing it back out to this writer, and that writer is just writing it back to disk, back to storage. I created a second one. That's a little more interesting. So here I'm reading that same data back in off a disk, and again, this doesn't disappear. I happen to have a cluster running right now, but it doesn't have to be there for this. No, this isn't the one I wanted. Here we go. I think this is my guy. Okay, so here we're actually going to run a clustering algorithm. So you read the data in, it goes out and gets it from that file. Here there's a lot of columns in it, and so here I'm filtering it down using R. I could have done this with a filter task over here. Again, I wanted to see how the R worked. To run a cluster, you have to choose a cluster and you have to initialize it, which is what this task does. And here it's telling it, where I said over in Excel I wanted 5 cluster points. Here's our centroids. This is the method it's going to use to measure the distance between the points. That's what clustering is all about. Several schools of thought on how you get from one point to the other, whether it's a straight line or they call it Manhattan, it's a city block, or exactly how that works, and how many iterations to run before it settles on an output. And we get to the actual training where I actually execute it. And here I've told it these are the columns I want to use, and then we take the output and we write it back out to storage. So it's really, it looks a little daunting when you see some of the examples they put together, but if you think about it and don't get overwhelmed by it too fast, it's really not all that bad. All they're really doing here, they're reading data in, they're doing some cleaning, determining what to do about when they have empty values. Here they've decided to replace empties with 0, which, back to the data science training side, you really have to be careful about what you do. You may or may not. If 0 isn't appropriate, you don't want to use zeros, and that's, again, more just a lot of discussion on that too. As a rule, the mean of the values in, I'm probably going to get nasty grams for this, the mean of the values for that particular attribute is a reasonably good value to use almost all the time. I'm trying to throw enough qualifiers in there that people don't yell at me. What happens if you arbitrarily set some value? If the value range is, if you're looking at sales and the average, you can't skew sales, so in that case you would want to put 0 in there. But here, you're looking at automobile price data, not automobile sales. So would I put, if I don't know the price of a vehicle, you have to make a conscious decision or run this multiple times. If I put 0 in there and include that record, what does that do for me? That implies that there are vehicles that don't cost anything, which is wrong. Or would you put a mean of vehicles, vehicle prices based on similar criteria, maybe from the same manufacturer, similar model, similar features? Would you pick some value nearest neighbor, is what they call it, where you take the model that's used another clustering algorithm, say these are similar classification algorithms, say these are the same, but this is its closest neighbor, that's more expensive, and this one would be his closest neighbor that's least expensive or less expensive, and you pick a value in between. You know, what you do with those empties is could radically impact your your analysis. So back to the topic, reading data in, figuring out what to do with the empties, and then they take that output and they send it to 3 models. And here they're doing 3 different types of regression against it. So they take the output of they cross-validate using these 3 different models. So this gives them a chance to try to fit a model, is what they're calling it, which one produces the best results. So is it, you know, is this a, you know, if we're trying to predict the price of something, that would be a good linear regression model or scenario. If we're trying to determine which features might drive the price most. I can't speak to the Poisson. Don't know enough about that one to talk much about it. So bottom line, they're just splitting this up and running multiple regressions against it, and then comparing comparing output. So similar models, similar but certainly more complex models. The beauty of all of this is if you understand the workflow, you can build something that's you know, fairly easy to put together. But as in all cases with running doing any data mining per se, you know, beyond basic, you know, I want to run a sales forecast. You're going to have to know something about analytics. And way back to the topic. So what does that do for us as far as, you know, the decisions we make and what problems we try to solve, the questions we ask, and what problems we try to solve? Well, we have to be very careful to make sure we understand the risks and where the potential error is, and what error we may have introduced in the decisions that we've made. You know, there's kind of no way to go from point A to point Z without a little bit of intuitive something or other. You know, which models do we want to, which algorithms do we want to run, or you know, do we want to run several? We're still, you know, none of them are likely to fit perfectly. You know, so what's acceptable, and what's the impact of the difference between acceptable and perfect by the time you get down here. Let me go back to presentation for a minute. So let's talk a little bit about, sorry, let me get this back up here so I can move to the next one. So how do you go about implementing this in your business? You know, first off, I'm going to jump around kind of all over the place. There has to be a problem that's worth solving, you know, unless you're just playing around. And even playing around, you know, if you have time to invest and you want to look at things, you know, that's great. Typically, these are not going to be, you know, small efforts, and typically without a little bit of forethought, you could come up with, you know, as the analyst or the data scientist, if you will, you could come up with answers to problems that could be very wrong, you know, without really sitting down and applying a lot of thought to it and going, okay, does this, I use the words, you know, does this smell good? Does it smell right? That kind of points to an article I read a few days ago by a data scientist who was complaining about people going through certificate programs like I am, and coming out and claiming to be data scientists, and he's going, well, you may know the mechanics of how to do all this stuff, but you may not know how to actually apply it to the business. You know, it's like building out a data warehouse, you know, in a black box. You know, you know all the tools to do it, and you can certainly build one, but does it fit the business need? And you know, there's a, you know, he listed off about 20 different, 20 more qualifications that he felt you needed to be a real data scientist, which, you know, there's definitely some merit, you know, and that's where if you don't have a lot of experience in business, then it may be interesting, it may be important, you know. Another article I had up a little while ago. You find a lot of articles out like this that, you know, having any one of these, as this article points out, is probably not enough. You really need to have, you know, several of these under your belt. And in particular, in my mind, is understanding, you know, business. So, because if you don't, then you're likely to come up with a lot of solutions or suggest efforts that the people that actually have to write a check to pay for it will quickly, if not immediately, determine there's little value in it, little return on investment, and you're going to wind up looking bad. So a lot of what you do, you may want to do, you know, with some supervision, or at least play around for a while, and then maybe, you know, bring somebody in, you know, maybe somebody over in the, you know, if you're not an analyst, if you happen to be, you know, a database developer, T-SQL developer, whatever, bring somebody in that is an analyst and go, you know, I've done all this stuff and I'm looking at these things and I keep finding, you know, this thing, you know, I know, and this is where being part of the data services layer, you have a, you know, a strong hand over, you know, people with statistics background. Somebody that just came out of college, essentially, is who I'm going to use as the alternative. Somebody that doesn't have database experience and hasn't been in your particular environment, more than likely you understand what's in your data. You know something about your business because of you've looked at the data and you've had to know, well, how did this get here, and why are these values in this range, and why did I have this problem? You know, just you're going to inherently learn something about the operation of the business, if nothing else. So you do bring something to the table more than you know, more than just, you know, your database skills. You know, by default are going to know something about your business. So if you learn a little bit about you know, some machine learning, you know, this stuff, depending on what you want to do, is not that difficult. You know, I'll qualify that. It can be, depends on what you want to do. You know, there are so many models existing and so many that have proven performance that if you do a little bit of reading and learn a way to do it, whether you do it via Excel or R or Azure, it doesn't take all that long to figure it out and get to the point where you can make a prediction, you can run these algorithms, and you can quantify the accuracy of your model. And that's really what it all comes down to. So get this out of the way. So as with any project, you know, being clear about what you're trying to do up front, even if it's I'm going to play around with this, you know, maybe you've seen some things, or maybe somebody's asked you some questions, or you heard somebody, you know, somebody off in the C-level end of the business go, if I just knew blah, 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 I could something. So maybe you take it upon yourself to go do a little digging and fire up some things. You know, Excel, almost everybody has it. By the way, this to do these, run these clusters, these algorithms in Excel, you need an instance of analysis services 2008 or better in the background. Excel doesn't actually do it. It's just the interface. It passes the data off to analysis services. It does the work on the AS server and then passes it back to Excel. So there is a little requirement there. You can deal with this machine learning stuff. Again, the storage accounts out on Azure are, I don't think I've incurred more than a few dollars worth of charges for the bandwidth I've used. And the machine learning environment right now appears to be incurring no charges either. So I've had these machine learning, 2 of them created for close to a month, maybe longer, and I have no charges for them yet. That probably will change. As I do the compute out there, I do get some charges. I think I showed that in my, yeah, this guy. So they charge by the hour, and I think it's 35 cents. And this said I had, I don't know how we'll call this, 6 hours maybe. We'll call it off here, nothing. So we'll call it 6 hours. And I don't know, they also probably charge by the core that it's using. There could be 16 cores, so it might be costing me a couple dollars an hour to do this. I'll keep you posted, let you know how that works out. If I have to, I'll call Microsoft. I did on their some of their HD Insight clusters costs. But anyway, a lot of you can get access to this for virtually nothing. And here you have far more capabilities than you do in Excel to dive in and really understand some of these other some of the algorithms and how they work. And much like the data scientist said, a lot of what he brings to the table is 20 years of playing with this, just like you probably bring umpteen years or some number of years worth of SQL Server experience. The best way to get into this and to figure out how to deal with all this stuff is to practice. Just get out there and allocate some time, jump out and have some fun. So I'm going to wrap it up at this point. So this is my website, iheartbigdata.com. You can email me at mreed@iheartbigdata.com. I have, you can email me at PragmaticWorks as well if you want. It's mreed@pragmaticworks.com. I do have, if you're interested, you can sign up on my website. Give me an email address and I'll send you an update as I get things posted. Right now I have my part 1 of this series posted. There's a total of about 29 literally 29 videos out there. I'm still working on part 2, and now I have part 3. I think part 3 here I'm just going to break down to some short discussion and probably a high-level demo of Azure Machine Learning and a high-level demo of Excel, and then I'll dive into each of the algorithms and building each of the components and talk about those and provide some fairly in-depth detail, and then I'll build some use cases out. So if you need to get a hold of me, that's the place to go, or again, you can email me here at PragmaticWorks. Any questions?
Yeah, you've got one. It's pretty long, so give me a second. Okay.
Okay.
What can be done to productionalize a model beyond its initial development, say on a monthly basis? What happens when the data changes from month to month in such a way as to invalidate the model or degrade its usefulness? Does it need to be run on demand always? Can validation be automated?
Yes, all of it can be. So there's kind of a mix there. I'm not sure what your data is doing that would actually invalidate the model itself. It might invalidate the results, but you would hope the model itself would still hold true. If the model is invalidated, that would indicate that the behaviors of your data has changed, in which case you're probably back to square one. And yes, you should have hopefully detected that by rerunning, you're automating the execution. I didn't show you that out on Azure. They do have a scheduler. So however you choose to do it, you should be rerunning it, and you should be running the validation every time you run it, just to make sure that you are still within parameters. You know, you're within your, if I said I want a, you know, an 80% or 95% confidence in something, that you're still at that confidence level, and if it moves from there, then yeah, you'd have to go back and look at your model, because it's indicating that your fit has changed. So I would hope that your model wouldn't be wrong. If you see that, it probably means it wasn't exactly right in the first place. Maybe the inputs, the columns you chose as the input variables are really not as strong as you thought they were, so maybe your classification modeling was off, something like that. But yes, it absolutely should be run and rerun and revalidated, and you really don't want to be making significant business decisions on data that is incorrect. So hopefully that answered the question. Anything else?
Nope, that was the only question.
Okay. Well, again, thanks everybody so much. If you have questions, I don't actually have a blog out on that IR Big Data site yet. I will probably, I have probably after 3 today, I will add one to the site. If there's anything out there, anything you want to ask, any suggestions on case studies you'd like to see, let me know, because I'm intending, now that I have all these webinars out of the way, I'm intending to keep building a library of here's how to do things. I want to get off into the Hadoop side and away from, for the people that aren't interested in Azure. I want to provide some support there. There is, by the way, a tutorial out on my site now about how to set up the Hortonworks sandbox and get it up and running. They have a great set of tutorials, great place to start if you don't want to mess with Azure. So check it out, let me know, stay in touch. If you do give me an email, I promise you will only see, you would never see more than one a week, and probably less than that. Depends on what I happen to accomplish. But I will get a blog up so you can tell me what you think, good, bad, or otherwise. So thanks very much for attending.